Photovoltaic cells are the subunits of solar panels. Each panel is made up of multiple cells. This demonstration will require small solar panels, alligator clips, a protractor, a light source like a flashlight or smartphone camera, a multimeter with a DC current setting, and a pencil and paper. Using a program like Excel would be extremely useful for understanding relationships between the measured variables. The power produced by a solar panel changes based on the angle of the light on the solar panel. It is most efficient at a 90-degree angle. The light source should be held about 3 inches from the solar panel, and the angle of the light source can be changed to mimic the rotation of the Earth throughout the day as well as the changing angle throughout the year. You should take measurements in increments of 10 to 15 degrees to get a full range of data. You can start taking data at 90 degrees and decrease to 0 or vice versa. What really happens is the Earth moves with respect to the light source, the Sun, so it looks like the light is coming from a different place. Throughout the day it rotates and the east to west angle of the Sun changes. Throughout the year, the Earth revolves around the Sun and the north to south angle changes. This affects the length of the day as well as the seasons. This experiment is easiest if students work with partners, with one student conducting the experiment and the other taking data. To take data, students should attach the leads from the solar panel to the multimeter with alligator clips. The multimeter should be set to DC current mode to read the energy output. I'll now show you a brief demonstration of what it should look like when you conduct the experiment. I've created a sample of what data we will be taking, but this data could also be entered straight into Excel. For the sake of demonstration, I've also added a voltmeter to this experiment. The voltmeter is on the left and the ammeter is on the right. We're taking measurements at 0, 15, 30, 45, 60, 75, and 90 degrees. You can alter the distance between the light source and the solar panel to see how distance changes the power produced. This experiment can be altered in many different ways depending on the student's skill level. The students can record data for each angle of insolation that they measure, and it can all be graphed on Excel so that relationships can be evaluated. This could be done on any scale, from each student graphing it independently to pooling the class's data. As you can see, the closer to perpendicular the light source is to the solar panel, the higher the amount of current or voltage produced. This means that a larger amount of energy is produced.